Okay, this is lesson 2.5, slope and linear equations in any form, not from Khan Academy. Our Math 1 skills are from forms of linear equations. These are skills 10 and 11. Your objective is that you'll be able to find the slope of an equation in any form, and you should also be able to write the equation of a line in any form. So remember, we saw 3 different forms: slope-intercept, point-slope, and standard, or it might be some non-standard form. Any form of line you should be able to work with now. So let's say that you want to find the slope of a line, and the line is given in slope-intercept form. Remember, that's y equals mx plus b form. Remember that the m value, the slope, is it's going to be next to the x. Slope tends to be attached to the x variable. You'll also see that not just in slope-intercept form, but you also see that same m, that slope, in point-slope form. It's attached to the parentheses with x in it. So let's go ahead and do that first example. When we have y equals 4 plus 2/3 x, keep in mind that's a little bit different. They switched the order on us. Instead of y equals mx plus b, it's written as y equals b plus mx. Remember, for addition, the order doesn't matter. You can switch it. That's okay. But don't get tricked into thinking that 4 is the slope. Our slope is next to the x, so our m is 2/3. Go ahead and try this practice problem. Tell me what the slope is in that equation. Okay, hopefully you saw that -5 was attached to the x. It's in slope-intercept form, so -5 is our slope. All right. Another form that we've learned is point-slope form. That's this equation here: y minus y1 equals m times the quantity x minus x1. Again, that m, that slope, is attached to the parentheses with x in it. So in our first example for point-slope form, we see that m value there next to the x. Our slope is going to be 6. Go ahead and try the practice problem for this one, then come back and check your work. Our slope is next to the x. It is -1/5. Okay. If it's not in point-slope form or not in slope-intercept form, if it's in standard form or really any other form, you might not be able to pick out the slope right away just by looking at one of these equations. So you'll need to solve for y. If you get y by itself, you're essentially getting it in y equals mx plus b form, or slope-intercept form. And when you have it in slope-intercept form, then you can pick out that slope because it's attached to the x. So let's go ahead and try this example problem here. Y is not by itself, so I'm going to add 9x to both sides to cancel out the -9x. I'll get y by itself on the left side, and we'll have 9x plus 82, and that's in slope-intercept form, so we know that our slope attached to the x is 9. We'll try the next example. This one's a little different because we actually have y on both sides of the equation, but that's okay. We can keep the equation balanced, combine our like terms, and still solve for y. I'm going to subtract y from both sides. So I'll be left with 2x plus 8y equals -80. And I can subtract 2x from both sides to get 8y equals -2x minus 80. And then if I divide everything by 8, I'll end up with y equals -2/8 x minus 80 over 8. And those fractions reduce, so really I should probably write it as, well, -2/8, that's -1/4 x, and that'll be minus 10. So our slope is attached to the x, It's negative 1/4. Give these 2 practice problems a try, and then come back and check your work. All right, so for this practice problem, if we subtract 6x from both sides, then it's in standard form, or not standard form, slope-intercept form, so we can see the slope is negative 6. In the next practice problem, we can add y to both sides. That'll get rid of y on the right side. We'll be left with 2x plus 5y equals 6. And then we want to isolate y, so we can subtract 2x from both sides so that the y term is the only thing left on the left side. We'll get 4x on the right side. Dividing both sides by 5 would give us y equals 4/5 x. You could call that 4/5 x plus 0 if you really want to show that it's in slope-intercept form, but either way, the slope is 4/5. On the next page, the directions got cut off, so can you please write the directions at the top? It should say, write an equation for the given graph. So you're given this line on the first graph, and again, there's actually 2 ways to do this. If you prefer point slope form, the y minus y1 equals m times x minus x1 form, then I'll show you that way in a moment. I will also show you how to use slope-intercept form if you prefer that way. So let's start with point slope form. Looking at our graph, I can see that there's lattice points here, so we can check the rise and the run, or draw our slope triangle to find the slopes. That's 1, 2, 3, 4, 5, 6, 7. It went up 7, so that's positive. And it went to the right, 1, 2, 3, 4, 5. That's also positive, so our slope is the rise over run 7/5. Our point, you can pick either point. I see 2 lattice points that we pointed out earlier. That first one there has the coordinates -2, 4. But if you rather, you could also have said negative, what is that, -7, -3. That would have worked as well. And then you plug those values in. So we'll have our point slope form says y minus y1. I'm going to use the first point here. The y coordinate of that first point was 4. That should equal our slope, 7/5, times x minus x1 was -2, so that'll be x plus 2 in our equation. This equation represents the line that we were given. If instead you want to use slope-intercept form, we can tell that the slope, well, that was already given. The slope is 7/5. We found that out already because we drew our slope triangle in red. But if we want to find b, it's important to notice that this is a good example where the y-intercept isn't a nice number. It's not a lattice point. It's just somewhere between 6 and 7. So we can't really pick it out and just know what the b value is, what the y-intercept is. So instead, here's an idea. We can plug in a known lattice point that's not the y-intercept, like the 2 that we noticed from earlier, and then solve for b. So in our slope-intercept form, y equals m x plus b. That should actually be parentheses. I'm going to plug in one of those points that we knew from before. So when x was -2, that's this point here, y is 4. Now everything's a number except for b. We can solve for b and then put that back into our equation. So we'll end up with 4 equals 7/5 times 2 is -14/5. So if we add 14/5 to both sides, we'll get b is 4 plus 14/5, which is, well, 4 is 20/5, so that would be 34/5. So now that we know our b value, we can say that in slope-intercept form, the line would be y equals 7/5 x plus 34/5. So again, notice that 34/5, that's not a nice integer value, but it's that number that's somewhere between 6 and 7 that we saw on our graph. That'd be our y-intercept. Okay, try to come up with an equation for the line in the second graph. You can use either method. I'll show you both solutions in just a moment. Okay, if you chose to use point slope form, I chose to use this point here as my x1 and my y1, and my slope triangle, I went down 4 and to the right 3, so that's -4 and 3. So that's how we got this slope here. And then we plug those values into our equation, and that's the point slope form of this line. If you chose to use slope intercept form, this one was actually a nice lattice point for our y-intercept. It was -1, so we plug in our slope in our y-intercept, and we get our equation for the line in slope-intercept form. All right, and the last thing for this lesson is the application problem. I went ahead and underlined some important information. So it says that there's a daily fee for renting a moving truck plus a charge of 50 cents per mile driven. It costs $64 to rent the truck on a day when it was driven 48 miles. So they ask us to write the point slope form of an equation to find the total charge, and they give you some more information here. The charge is going to be a y value, and the number of miles driven is going to be an x value. We haven't done too many word problems like this, but we will, and you'll get more experienced with it. But for now, I'm going to give you a hint. Since they told us a value for the miles driven, 48 miles, that's going to be our x value. That is paired with the cost of $64. That was our y value, our total charge. So if we're thinking of this as a line, the point 48, 64 is the point that we're given in the word problem. I want you to figure out what the slope would be and then write something in point slope form. Remember, so write an equation for that in part A. I want you to try to write it in slope intercept form too, and then tell me what the daily fee would be. And we will go over that in class. Don't forget to type a question at the end of this video, and I'll see you all in the next class.